yes, already we have dealt with this, right? We have already dealt with this, but I'm just giving you a different perspective. Again here, Vp is equal to Vp with respect to C plus Vc. The velocity of the lowest point of P. Okay, I hope you are reading this. Take an uniform discovery, place it vertically or smooth or spin the disc and simultaneously push it. In consequence, the disc will rotate angular velocity. The velocity of the lowest point is going like this. See, now please try to understand. This is with regard to what is written here. That is, you are spinning and you are pushing.
Pushing, yes.
You remember, I started my journey like that. Okay?
Yes.
So, when you are spinning and pushing, okay, when you are spinning and pushing, the velocity of P with respect to center and the velocity of C. Right? Hello? The velocity of the lowest point of... See, please, are you with me, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
See, because it is rotating, there will be a velocity component Vpc in this direction.
Yes.
Yes.
And there is,
Yes.
since you have pushed it, there is velocity Vc. Okay?
Yes.
And it is not yet touching the surface. You can see that there is a gap here. Hello?
Yes.
Yes, sir.
See, because there are some numericals that you have to work with these conditions. That is why I am just revisiting this with this perspective. Now, Vpc is minus R omega I cap, Vc is V I cap. So Vp will be V minus R omega I cap. Okay, this is the basic equation. See, because, my dear friends, why I am doing this, I'll tell you. Because now we have said rolling without slipping, provided the surface was at rest.
Yes, sir.
Now, supposing the surface is also moving,
Yes, sir. Yes.
Yes, sir.
the surface is also moving, then what are the conditions? So, to handle these situations, I am starting this theory like this. So, therefore, we get this general equation Vp bar is equal to V minus R omega. Okay? Now you see in the above expression tells us that for different V and omega, the point P will move with different speeds. 1 minute. Can you hear me?
Yes, sir.
Yes, sir.
So, the above expression tells us that for different V and omega, the point P will move with different speeds. So, that means now the speed at point P will depend upon Vc as well as it depends upon omega.
Yes.
Okay, that's what I want to say. This is very clear. P will move. For suitable velocities of V and omega, let us assume that P moves with velocity equal to the velocity of horizontal surface, that is Vp is equal to Vs. Then it means relative velocity of P and S is 0. That is, you can see this diagram here. This flank down is also moving with Vs, and this disc, the point P of the disc is moving with velocity Vp, and Vp is equal to V minus V
Plus
because omega is now changed. Okay, omega is now changed here. V plus R omega. Here it is V minus R omega because it is clockwise. It is anti-clockwise.
Yes.
So that means now the velocity of P and S is 0. The relative velocity is 0. There we can say that P does not slide on the surface S. In other words, the body is said to be rolling without sliding on the horizontal surface.
Yes.
Okay. For this purpose, we have Vp is equal to Vs. So Vp is equal to V minus R omega I cap in the first case, and V minus R omega is equal to Vs. If you assume anti-clockwise rotation, reverse the sign we obtain, we get this. When the horizontal surface is stationary, then when the horizontal surface is stationary, then what do we get here? That is Vs is equal to 0. Then V is equal to R. The body in combined motion is said to be pure rolling or simply rolling over the surface if the surface is in contact do not slide slash slip relative to each other. It means that the relative velocity between the points of contact is 0.
Yes, sir.
Understood?
Yes.
So,
Yes.
see, we started our journey by saying that, we wrote this equation that it is rolling without slipping, and we started. But now that, you will have to encounter situations where the platform itself is moving with some other velocity.
Yes, sir.
And the disk can rotate clockwise or anti-clockwise direction.
Yes, sir.
Be aware about it. Okay?
Sir, this V is equal to RM here, sir.
Huh.
Now, if you take the case of anti-clockwise rotations of the disk and surface is at rest, sir, that time VP, sir, if the velocity of center of mass is towards right direction, that time obviously these conditions say that it will just slip, no, sir, because there is no velocity to counter it.
Hey, see, why are you unnecessary? Why are you confused?
Sir, like this V is
See,
equal
now this condition you understood, this
That-
condition, this
yes,
condition
last-
understood.
last condition is only true for clockwise direction.
Obviously,
Anti-clockwise it cannot.
anti-clockwise, no, anti-clockwise we already dealt here. No. See, this equation is for anti-clockwise.
Clockwise.
This equation is for anti-clockwise.
Clockwise. V minus R.
V minus R.
Yes, sir. V minus R minus.
What is V? V is this. This is for anti-clockwise only, no?
Clockwise?
V is, clockwise. This is for clockwise.
Yes, sir. Yes.
And this is for anti-clockwise. These two equations are right in front of you.
Yes, sir. That I understood, sir. Then down they give when horizontal surface is stationary.
That means you just put Vs is equal to 0 in both these equations.
Yes, sir. If it's
In both these equations, if you put.
Yes, sir.
Okay, what happens then if you put in both these equations? Then here it is V is equal to R omega.
R. Yes, sir.
And here V is equal to minus R omega.
Yes, sir.
Then it will slip.
There.
Then it will slip. Obviously it will slip.
Yes, sir. We had what, sir? Only when.
See, his doubt is now this plank down is also moving to the right.
Yes, sir.
And the wheel is also rotating like this.
Yes, sir.
Then at this point, if the velocity of VP and velocity of the plank are same,
Yes, sir.
okay, then this is rotating and moving, this is also moving.
Yes.
So there is no relative velocity between these two.
Yes.
Okay,
Yes.
that is what was the thing. Now in case it is doing like this, it is rotating like this, and the plank is moving like this. Okay, that is the condition he is asking.
Sir, slipping.
See,
Slipping
slipping.
what happens if it's clockwise or anti-clockwise?
It is saying that plank is stationary. so
Yes, sir.
like,
Plank is stationary.
it is rotating anti-clockwise and moving to right. So not
Yes. That minus states the direction. If it's anti-clockwise, you go to
Okay, fine. Okay, I was understanding him properly. You understood your friend correctly. Okay,
state.
fine, understood. So body combined motion set to be pure rolling or fusion over the surface. If the surface is in contact, do not slide, slip relative to each other. It makes sense. Okay, so we will.
Sir, that gap, why do we take this?
I'll tell you why. Because we are developing a theory now.
Yes, sir.
We are developing a theory now. If supposing there is a numerical where this is the situation. Okay, this is the situation, and then this is say clockwise or anti-clockwise rotating, and then it lands on the surface,
Yes, sir.
and the surface at that moment is already moving. So
Yes.
you see, it's like you be prepared. See, this is the basic equation. So you put surface is at rest, Vs is equal to 0.
Yes, sir.
That's it. So these equations become very simple. That's what they want to tell you. We will see now. We will see some numericals based on this. Okay? Because I am going to keep one plank down and one plank on top.
We have done that.
Okay? So to handle those type of situations, this
Yes, sir.
equation is ready for you. Okay? Now one more concept I wanted to say here. So this is, there is a shaft axis. So this you can see here, this is the plane of rotation. Okay. Now the axis of rotation is now tilted. So you can see that the plane of rotation is also tilted. Understood now? Plane of rotation will be perpendicular to the axis of rotation.
Yes.
Okay. Because we are going to use this concept, so I'm just showing you this diagram.
Shaft axis.
Yes.
Shaft axis is this. For example, now helicopter.
Yes.
So helicopter will be like this.
Yes, sir.
So the tilt of this one can be like this.
Yes, sir.
Okay, so that is from that only I have extracted this diagram. So now don't confuse yourself. Okay, see, because the helicopter will be like this, so the the shaft can be like this. I mean, the axis of rotation can be like this.
Yes, sir.
That is what is. Now, gyroscopic motion, when the plane of rotation changes, even though the magnitude of the when the plane of rotation changes, even though the magnitude of the angular velocity may remain constant, its direction will change, isn't it? See, now something is rotating like this. So the omega bar is up.
Yes, sir.
Now omega bar will tilt, but magnitude is same,
Yes,
but only the direction has changed.
Oh, yes, sir.
So
Yes.
its direction will change. This type of motion is called gyroscopic motion. That is, magnitude is not changing, but the plane of rotation is changing. The change in the direction of angular velocity. What is important is the change in the direction of angular velocity will give rise to angular acceleration, which is different from that described in the previous section due to change in the angular velocity. Okay. And now what it means is. Okay. So what it is meaning here is that the okay. So the change in the direction of velocity. See now, say this is rotating like this, and this is the axis. So this is rotating like this. So obviously omega bar is up. Okay, fine. Now you see this this whole body. What is this? Supposing you say this is the disc. This disc is rotating, right? And this disc is rotating, so omega bar is this. The disc as a mass, with respect to this point, this disc itself will rotate.
Yes.
Yes.
That is as good as there is a mass here, that mass has changed its position. So with respect to this point, this mass has now tilted.
Yes, sir.
Yes.
Its orientation has changed. Okay, and this by itself, see, it will not change like this, because now if the disc is rotating like this, then its angular momentum is conserved.
Yes.
Angular momentum is conserved.
Yes, sir.
Okay. Now, if you want that system which is rotating like this to come like this, if it comes like this, what happens? The angular momentum has now changed.
Yes.
So just like how momentum of a body will change due to external force,
Yes.
angular momentum will change due to external torque.
Yes.
Understand? So therefore, a torque must have acted on this. Therefore, its angular momentum is now L dash. And the change in the angular momentum from L dash to L, okay, is a consequence of external torque.
Yes.
Are you aware with me?
Yes, sir.
Yes.
And external torque divided by the moment of inertia of this about this point
Angular acceleration.
will give you angular acceleration, and that is different.
Yes, sir.
Yes.
Okay. See, now this omega changes. Then you will measure that as alpha. But that is, this body's speed changed.
Yes, sir.
Angular speed changed. Then it is alpha.
Alpha is.
But this orientation itself has changed.
Yes.
That is a different alpha.
Yes.
That's what is pitching.
Yes, sir.
Yes.
Yes, sir.
Okay. So when a plane of rotation changes, even though its magnitude or angular velocity may remain constant. Okay. So the change in the direction of angular velocity will give rise to angular acceleration, which is different from that described in the previous section. Just a mention of it. We'll handle that later on. So rotation about a point. Sometimes we see sandbags hanging from rigid supports, such as you can see where they are rotating. So you will see in big Mandi Bazaar and all, you will see this, when sandbag is lifted here. So there will be a hook. So if it is rotating like that, it will rotate. And if you change the hook direction, so that sandbag will still keep rotating, but its axis will keep changing. It's just an illustration because we are going to use this in some numerical.
Okay, sir.
Now I have a question for you here. Will the relative acceleration along the line of their separation between any 2 points be 0? See, now we know that in a rigid body, so there are 2 points. There are 2 particles, 1 and 2. And we know this distance is fixed. Okay, that is aspect we know. Now please try to answer this question. It's very simple. Will the relative acceleration along the line of separation between the 2 points be 0?
No, sir. Need not be zero.
Need not be 0. Anybody else? Hello? See, the thing is, hey, sandbag alla ಒಂದು ಹಿಂದೆ ಏನೋ ನೋಡ್ರ ಅದನ್ನ ನೆನ್ಪಿಟ್ಕೋಬಾರ್ದು ಈಗ ಅದು ಮುಗೀತ.
Yes, sir.
See, I wrote here, there is a rigid body and I am marking 2 points there. Okay, this distance between them is constant. And even the velocity along this direction,
Yes, sir.
that is the velocity along this direction, the relative velocity between point 1 and 2 along that direction will also be 0. Yes or no?
Yes, sir. Yes, sir.
ಏನಪ್ಪ?
Need not be.
See, in a rigid body, Srijan, listen very carefully. In a rigid body, the velocity, the relative velocity between this and this along this line.
That is.
Sir, the centripetal acceleration.
When I'm talking velocity, why did you say acceleration?
Sir, you said
I am discussing. I was telling you velocity. The velocity along this line. The relative velocity along this line between these 2 particles is 0. I said.
Yes, sir.
yes, sir. Velocity.
That is yes or no?
That is.
Yes, sir. Yes, yes, sir. Yes.
Now, Srijan, just for a moment, just excuse me, don't answer. Okay, let others answer. Other students. So the distance between the 2 is fixed; it will not change.
Yes.
And the
Yes, sir.
relative acceleration of point 1 with respect to point 2 along this line will also be 0.
Yes, sir. Yes.
Then the relative acceleration between point 1 and point 2, it should also be 0. Yes or no?
Sir, no, sir.
No,
Need not like always.
need not be. Why?
Sir, like whatever tangential acceleration we take, sir, that relative velocity will be 0, sir. The 2 points 1 and 2 when they are rotating in a plane, sir, the distance from the center may be different, sir. The centripetal acceleration acting will take omega.
Why are you bringing so many other things, man? I am just telling 2 points in this rigid body. I am just bringing 2 points in this rigid body. And just see, you should follow my discourse. In a rigid body, I am considering 2 points. The relative distance between them or the distance between them will be fixed. It will not change.
That is not.
And the velocity along this axis, that is the line joining 1 and 2, the relative velocity of 1 with respect to 2 will also be 0.
That will be.
And therefore the relative acceleration of point 1 with respect to point 2, that should also be 0. Yes or no?
Sir, it will not be zero.
It will not be 0. Why?
Sir, along that line it may be zero, sir, but see again, look with respect to, it will have tangential acceleration.
I am asking you along that line, man. Why are you talking about tangential acceleration? I am asking you the relative velocity along. See, I told you the relative velocity along this line 1 and 2 is 0. Okay. Now the relative acceleration between these two points, can it be 0 or no?
Along that line, sir.
So if the distance from center.
See, will the relative acceleration along the line of separation between 2 points be 0?
Sir, yes, sir. It will be zero. Sir, if the distance r is same for point 1 and 2, then it will be 0.
Sure.
Sure.
Everybody,
It will never be zero.
it will not be 0. Why? This is while the rigid body is rotating.
Rotating, yes, sir.
While the rigid body is rotating, we are discussing. Why do you say, Mr. Om?
It will always have centripetal acceleration.
It will always have
Yes,
centripetal
sir. If
acceleration.
radius is same, it will be.
Yes.
Sir, if radius is same, sir. Like,
Why are you telling radius and
sir,
all?
not radius, like the distance from point 1.
See, this question is very simple. Will the relative acceleration along the line of separation between the 2 points be 0? Simple question. Why are you bringing so many things there? Centripetal, radius, all those things. Why you want to bring? Why you want to bring all those concepts?
Sir, if from the center.
These are 2 points. This body is rotating. Will there be acceleration along these 2 points
Yes, sir.
between on that line? Answer is yes or no. Simple. It is because see when this line is rotating, okay, when this line is rotating alpha or omega, right?
Yes, sir.
Then there will always be centripetal acceleration along the line, because the main thing is, see, this point, any 2 points will be rotating with respect to each other.
Yes, sir.
If this rigid body is rotating, any point you take, if I take this point with respect to this point, this will also be rotating. If I take this point with respect to this point, this will also be rotating.
Awesome.
With respect to this point, all points will be rotating.
Yes, sir.
Then along the line joining these 2 points, there will always be centripetal acceleration.
Centripetal acceleration.
That is the answer.
Okay.
Again,
What should I repeat, Mark?
now
Now means remote point. See, if you take a rigid body and if you take some point, some arbitrary point x, then if you take any other point here, and if you join lines from this point, this point, this point, and if this rigid body is rotating, okay, then all these lines are also rotating with omega.
yes, sir.
Correct? Are also rotating with omega, and therefore there will always be centripetal force acting along the line. And what is the value of that? Supposing this arbitrary line value is length is L and omega is this, then the centripetal acceleration will be omega square from this point to this point.
Yes, sir.
That is the answer. See, relative velocity is 0. The displacement of that with respect to this is also 0. Okay, but acceleration is not 0. Got it?
Yes, sir.
Yes, sir.
See, Neela, you were asking that time, sir, in that previous problem brought here, sir, acceleration is there, why displacement will not be there? See here, there is acceleration here, but there is no displacement.
Yes, sir.
Similarly, that case also.
Okay.
Is it clear?
Yes, sir. Yes.
Huh?
Yes,
Yes,
sir.
sir. Yes.
Done.
Yes, sir.
Fine.
Yes, sir.
See, this is what is centripetal acceleration. Centripetal acceleration's job is to ensure that the body's velocity direction changes.
So direction. Yes, sir.
Understand? See, force when it acts on a body, it does 2 things. One is it will change the magnitude
Yes, sir.
of the velocity, and it will change the direction of the velocity.
Yes, sir.
Yes, sir.
Yes,
And if the force vector is perpendicular to the velocity vector, it will only change the direction.
yes, sir.
If the force vector is along the line of velocity vector, its only magnitude will change. If the force vector is making some angle, okay, with respect to the velocity vector, then the component of the force along the velocity vector will change its magnitude. The component of the force perpendicular to that will only change the direction.
Yes, sir.
Got it?
Yes, sir.
Yes, sir.
Yes.
Fine. Now, this problem of the ladder, we have seen that. Okay, now with a different perspective, let us look. See, perspective what I am giving here is the length of this ladder is L. Okay, the angle made is theta. Now I created a frame of reference here, X and Y. Okay, that's all. That's just the perspective I have changed. So now, therefore, now you see dx. So this ladder is slipping. That means point A is moving to the right, point B is coming down. Same thing. So now I will, what is the coordinate of A? The coordinates of A is x0. What is the coordinate of B? 0, y.
0.
So therefore, if you differentiate this dx by dt, now if the length of the ladder is given as L, then x will be equal to L cos theta, and y will be equal to, y will be equal to L cos theta, x will be equal to L sin theta. And if you differentiate that dx by dt, then L cos theta, if you differentiate it, then it will become what? L sin theta will become L cos theta and d theta by dt. And dy by dt will be minus L sin theta d theta by dt. I suppose you understood.
Yes.
And d theta by dt, all of us know we can interpret it as omega. And now if you designate dx by dt as VA, that's what we did. Hello?
Yes, sir.
Dx by dt as VA, then dx by dt as VA is here, then omega will be equal to V by L cos theta.
Yes, sir.
Yes, sir. Yes, sir.
So why I am showing all this is because now you see, if this velocity of this point A is given, the length of the ladder is given, at a given instant if theta is given, then the omega at that instant will get related with this.
Yes, sir.
Yes, yes.
Okay, and similarly VB will be minus V tan theta.
Yes.
Substitute. Okay.
Yes. Yes, sir.
Now I am giving one more perspective to this. See, this ladder I am now showing it as a free body diagram. So here VA is here, and as you know here VB is here. So this is what a common feature in this rotational motion, rotational dynamics. We will take the vector along the length of the rod. So component of this VB will be VB cos theta will be here, and here VA sin theta will be here. Now VB cos theta and VA sin theta are equal.
Yes. Yes.
Equal.
And
Yes.
then that is why these 2 points A and B will be fixed. I mean, there will be no relative displacement between the two, or displacement between the
Yes.
two will not be there. And VA cos theta and VB sin theta. Okay, so now VA cos theta minus VB sin theta will be what? The relative velocity of point A with respect to B.
Yes, sir.
That means this
Yes.
point will rotate. So point A will rotate with respect to B, or point B will rotate with respect to
Point.
A. Point.
Yes, sir.
Yes.
Okay.
Yes.
So those aspects are brought up here. Got it? A different perspective.
So there's VB, sir. VB they wrote it as V tan theta. This is the third equation, sir. And they equated VB is cos theta and VA is sin theta as VC.
See, VB cos theta is equal to VA sin theta.
Yes, sir. That time.
That you understood.
Yes, sir.
Now for VA, they are giving the name as V.
V. Yes,
VA, they are giving the name as V.
V, okay, sir.
Okay.
Yes, sir.
So VB is VA cos theta. So V is equal to, if you take VB is equal to VA sin theta by cos theta tan theta, and for V they have made mu namkaran as VP.
Yes.
Okay, friends.
Yes, sir. Yes, sir.
So now velocity of B with respect to A will be V by L cos theta. Okay.
Yes.
In the above example, find the velocity of the midpoint of the rod. Now see, why all of this theory I have developed is because a set of numericals is based on that theory.
Yes, sir.
So
Yes.
so now if you have understood this theory, okay, then you can skillfully apply it and solve these numericals. Are you ready?
Yes, sir.
Yes.
Yes.
So in the above example, find the velocity of the midpoint of the rod. See, this rod is now going to move. So what is the velocity of the midpoint of the rod and the nature of the path traced by the midpoint of the rod? Madam. So how will you start? midpoint.
We have to take with respect to either A or B.
Velocity of the midpoint of the rod. The length of the rod is given as L. The length of the rod is given and we want to find the velocity of the midpoint. So what will be your first approach?
Take with respect to either B or A velocity.
No. See, this is the problem with all of you. If you are now solving problem on rotation, you will only think of rotation. If you are solving problem in translation, you will only think of translation. Now, you around think, how will you start? They are asking you velocity of the midpoint of the rod.
Yes.
So, from this data, first locate the midpoint.
Yes.
What is midpoint? What is midpoint? See, I give you XY coordinates, man. What will be the midpoint?
Midpoint.
Length of the rod is given.
L cos theta by 2 plus L sin.
Mata, first you write that. You write the midpoint of the rod in terms of L and theta. L by 2 sin theta, L by 2 cos theta.
Yes, sir.
These are the two midpoints. So you look at them, see from the information, from the data that is given, establish some information. When data is processed, it becomes information. Information processed will become knowledge. Knowledge and processed will become wisdom. This is the hierarchy. So from the data, you mark the midpoint. L by 2 sin theta, L by 2 cos theta. These are the x and y coordinates. Okay, so velocity of the midpoint of the rod. Now, what is this midpoint of the rod? If you take this rod, this midpoint, what is this midpoint? Hello, are you there, all of you?
Sir, L by 2 cos theta.
Yes, sir.
L by 2 sin.
Yes.
Anna, this L by 2, this theta kottara, this sin theta hodilla. Yeah, ha. So this midpoint will also become the center of mass, no?
Yes, sir.
Yes, sir. Yes, sir.
Yes.
Yes, sir.
Correct. So you have X COM and Y COM. So these 2 points for what? X COM and Y COM. Correct?
Yes.
So if you differentiate X d by dt of X COM, what will you get? You will get
2 cos theta.
Velocity.
you will get Vx COM.
Yes.
And if you differentiate d by dt of y COM, you will get by COM. See, they are asking now what? They are asking the velocity. So these are the two components that you have to get. So if you differentiate this first one, you will get here L by 2 cos theta. Okay. And cos theta will get to cos theta. This will get minus L by 2 sin theta.
And even d theta by d.
Into d theta by
Into
d.
d theta by d. That is, you will get into omega. Because theta is changing. Got it?
Yes, sir.
Hello.
Yes.
So therefore now VCM will be what? Vxi cap plus Vy j cap.
Yes, sir.
Yes.
Okay. So this straight away you can write it as omega L by 2 is common. Omega L by 2 is common. So you write here cos theta I cap minus sin theta
J cap.
You get this equation VC. Okay, so you have found out the velocity vectors, velocity of the midpoint or velocity. See, please appreciate now. You got one track pointer for that. Okay, so they said what is the velocity of the midpoint? Midpoint means first with the given data, if using the data that is given, locate the midpoint. Just do it. Don't think anything else. Okay. Now they are asking velocity of this midpoint. Now that is what I say. Intelligence. So you know what is center of mass. So nobody will come in the examination and tell you think about center of mass. So now what is this midpoint? Is it anything special? Can this midpoint be connected with some concept? Then your mind will tell, it is the center of mass. Then write the center of mass equation. You get this. Okay? Then what else have they asked?
Nature of path traced.
Nature of the path traced by it. So nature of the path traced by it. Okay. So how do you work on the nature of the path traced by it? So now see, when the ladder is completely with the wall. Okay. Assume ladder is like this. Then the midpoint is somewhere here. And then the ladder is completely flat. Okay, the midpoint is here. That means from here to here the midpoint has moved. But we do not know the trajectory.
Trajectories.
We do not know the trajectory of it.
Yes.
Okay, we do not know the trajectory of this. Okay. So now can we find out the trajectory of this? Okay, can we find the trajectory of this? Is a question. So that means now if you track the midpoint, so the midpoint is in motion. So the midpoint, and here you see it is giving an idea that it is omega is also coming there. There is also omega coming there. Coming there. That means now this ladder is rotating. This ladder is rotating. So what is happening to VC? Right? So if you remember the velocity vectors of this ladder, what are the velocity vectors of the what is the axis of rotation of the ladder? If you remember, it was somewhere here. Hello?
Yes, sir. Yes, sir.
Yes.
To begin with, it was here. And when this ladder is somewhere here, okay, here and here, right? So now the center of rotation is somewhere, the axis of rotation is somewhere here. Okay.
Yes, sir.
And so it keeps going, and when the ladder is completely flat, so this is here and this is still here. So the axis of rotation, where will be the axis of rotation just before it is about to land here? So it will be close somewhere here. Okay.
Yes.
So that's not giving an idea.
Sir, here we have written x is equal to L by 2 sin theta, sir. And y is equal to L by 2 cos theta. If you square and add them, you get x square plus y square is equal to x square by 2.
You will get that as a constant. Yes,
Yes.
because it is sin
Coordinate
theta
number.
cos theta. You will get, if you take the modulus of this, x component and y component here, modulus of this, okay, then you are going to end up with the L square by
L square by 4. Yes, sir.
L square by 4. That means it is going to form a circle.
Circle.
Yes, sir. Quadrant of a
Quadrant of a circle.
Quadrant.
Quadrant of a circle. So therefore, so XCO by CO we got it right. We got this equation also right, and we got omega and BCM also right. Okay, and XCM by L by 2 plus YCM plus L by 2 is equal to sin square theta plus cos square theta is equal to 1.
Yes.
X square plus y square is equal to a constant 1. So it is a circle of radius 1. Okay?
Yes, sir.
Huh?
Yes, sir.
See, so many things are getting related here. Okay, so many things are getting related here. Okay? So around you should read, that's what you say. Now, if you keep on solving chapter-wise problems, then you know your mind is very clear. This problem means okay, kinetics. This is there. This is there. But now you see, your brain power will be increasing, and your mindset will be continuously changing. Okay. Oh, it's already 8:30. I think we will stop the class now.